Good morning. We will start a new chapter from physics, chapter number 9, force and laws of motion. So, we all know what is force. In our standard 8, we understood force as anything that is push or a pull is called as a force. We understood the definition of a force as push or a pull is called as a force. But if you go still in deep to understand what is a force, force is an external effort in the form of push and pull. Now, anything we push or anything we pull, we call it as a force, but what that push is, how is that pull? So, that defines as an external effort. What is external effort? Some external thing acting on the object. So, force is an external effort in the form of push or pull that changes the body or object from rest to motion. That means force acting, external thing what is acting on a body, which is a push or a pull, how it acts in such a way that a body which is in rest is put into motion, a body which is in motion is brought to rest, a body which is in motion can change the direction, or the force can either change the shape or size of an object. So we define, there is no particular definition for a force, but we can understand the meaning of force, right? So basically, if I have an object here, an object with mass m, so this object has to move to a particular direction, right? That means it is moving with some velocity, that means it changes. If it is changing the velocity, if I am applying some force on this object with mass m, that object moves with changing in velocity. That is nothing but acceleration, right? So force we can define as a product of mass into acceleration. We actually have this derivation in this chapter where we will be deriving what is force, mathematical derivation of a force, which is nothing but a product of mass into acceleration. We call that as a force. So, what is a SI unit of force now? Let's define. So, mass is calculated in terms of NKS system as kg. Acceleration is calculated in terms of meters per second square. So, SI unit of force is kg meters per second square, where kg meters per second square is termed as Newton. Right? We write it as in terms of capital N or we write it in terms of Newton. So, force is measured in terms of kg meters per second square or force is measured in terms of Newton. Let's proceed further. Effects of force, that is what we discussed here. Elaborately, let us understand. Effects of force. Force makes a stationary object in motion. Suppose an object is in motion. Suppose if I have a toy car or if I have a ball which is in rest, that is a stationary position of an object, I can just push it, I can apply some Newton of force on a particular object so that it can move. That is, it brings about a stationary object in motion. Stop a moving body. So an object which is moving, I can stop the moving object, right? Change the direction of the moving object. Now how do we change the direction of a moving object? Let us take an example, of a toy car. Suppose it is a pull back toy car. So when you pull it and leave it, the toy car moves. Suddenly if I just apply some external, or if you have seen, if the toy car goes and hits to an obstruction, wall or anything, it will change the direction immediately, right? That is one condition. In cricket, when a batsman hits a ball and when a fielder tries to catch a ball, but what happens? It touches the hand of the fielder and what could happen? The ball can change the direction. Yes, apart from that, a batsman, a ball which is coming in a linear position, linear motion, that is a ball coming in a straight direction, a batsman hits the ball which changes the direction of the ball, correct? So we can say it can change the direction of the moving object. It is not that the batsman also has to hit it in the straight direction. He can change the motion of a moving object. Change the speed of the moving object. Yes. Again, the same example I would like to quote. A car hitting, a toy car which is going in motion, if it hits the obstruction, it immediately changes, but its speed decreases. Similarly, when a batsman hits a ball and a fielder tries to catch it, but accidentally he could not catch, but it just touched his hand and it moved to other side, that means the speed of the ball at that point of time has decreased, right? So it can change the speed of the moving object. Change the shape and size of a object. A very common example, you have a balloon or you have a dough which you can make chapati out of it. So you can change the shape and size just by pressing and molding it. Yes, or a clay what you have. So by the applying force, by application of the force, we can make these many things happen, which is possible. You all have studied these all basics in your standard 8, but as an introduction, we will again recapitulate that before we actually start with the content what is there in this lesson. Next, force are mainly of two types, that is balanced force and unbalanced force. So let us understand in detail now what is balanced force and what is unbalanced force. Yes, now by the name itself we can understand balanced force and unbalanced force. Now balanced is something which is equal, right? Unbalanced is something which is unequal. So here first we understand the definition, or not the definition, but the actual meaning of it, then we'll understand its depth. If the resultant applied force is equal to 0, it is called as a balanced force. That means, assume that we have a heavy box which is to be moved to the other side, right? So I and one of my friend try to push the box to the other side. But what we do here is, if this is a box which is a heavy box which is there, so I apply around say 5 Newton of force to push the box to the other side, right, along with my friend. But my friend, what she does here, she applies a similar 5 Newton force on the opposite side. That means we are pushing the box from either of the sides. That means if I am pushing the box from this side, my friend is pushing the box from the other side, and we are applying equal force. That is 5 Newton applied by me and 5 Newton applied by my friend. So what can happen in this case? Will the box move? No. The box will not move. It will be at stationary. The resultant applied force is equal to 0. Why 0? I am applying 5 Newton. She is also applying 5 Newton. So the resultant force, what is happening there? It's becoming 0. Why? Because the object is not displaced from its position. There is no change in the state of an object, equal in magnitude. So our forces are equal in magnitude, but in opposite direction. But sometimes it can change the shape and size. That means, suppose if this is a carton box, a heavy carton box, the possible force what we both are applying from the opposite direction, the carton box might get damaged. Or assume that if it is a balloon or something, if we are applying force on both the things, it can change the size, shape, or it might burst, right? So these are the possible things can happen. Change the shape and size in the way. Now we have a chapati dough or a clay. If we are applying equal forces on both the sides, that means it is getting flattened. But the resultant force applied is 0. Remember one thing, in balanced force, object is at rest. Object is not displaced. Take an example of a tug of war. Now what is tug of war? So there are two teams, two opponent teams, and you try to pull a rope to the either of the side, right? How the team wins here, whichever team applies or pulls the rope with a greater force, that team wins. Suppose assume that in a tug of war game, this is a line and these are the number of participants, these are the number of participants. Again same thing here, you are trying to pull this rope with 5 Newton of force to your side and the opponent team is also trying to pull it with 5 Newton. That means it is balanced. That means there is no displacement here. So the force where the resultant applied force is equal, it is called equal to 0, is called as a balanced force. Then what is unbalanced force? If the resultant applied force is greater than 0, it is called as a unbalanced force. In unbalanced force, object in rest can be moved. That means the object is displaced. Unequal in magnitude. Let me again take a tug of war game here. Right, this is a border point. So one team is applying 5 Newton of force to pull it to this side and another opposing team is applying 7 Newton force. That means the resultant force is greater than 0. Unequal forces are being acted on the rope. Which direction will the rope move? The rope moves of course to this direction and this team will win in the tug of war game. Right? We all have played this. Similarly in this box example, if I have a box which I have to move, I am applying 5 Newton force from this side. Okay, two conditions, let us assume that, and my friend is applying 6, okay, let me take 8 Newton. 8 Newton force from this side. So what is happening here? Which direction will the object move? Of course, the direction, the force, whichever is applying is greater, it will move. The object is displaced to this direction. One more example I'll give you. Suppose the similar box is there. I am applying 5 Newton. My friend is also applying 5 Newton. Another condition. I am applying 5 Newton. My friend is applying 2 Newton. Okay. What is happening in both the cases here? The force 5 Newton is getting added up. That means the box is moved very easily because the resultant force is more. It is getting added up here. 10 Newton of force is acting on the ball on the same direction. That means the box can move easily. Correct? Here 5 Newton, 2 Newton. But it is applied on the same direction. That means the box is displaced easily. So what we conclude from this is, in balanced forces, the forces are subtracted. Correct? 5 Newton from here, 5 Newton from here, subtracted, we got 0. That is why we say the force is equal to 0 because we are subtracting the force here. So in balanced forces, the forces are being subtracted. What is happening in the unbalanced force? In the unbalanced force, the forces are being added. So the object can move easily. So one thing you remember, definition of a balanced force, resultant applied force is equal to 0. That is, in balanced force, the forces are subtracted. No change in state of object, equal in magnitude. And one more thing, balanced force is always applied from the opposite direction, right? That you have to remember. Unbalanced force, the resultant force is greater than 0 and it is applied from the same direction, or if it is from the opposite direction, whichever side the force is more, it actually moves there. So one thing we remember, in unbalanced force, the object displaces its position, and in balanced force, the object is at rest, that is stationary. So this was about the basic introduction of the chapter, force and laws of motion. So where we discussed only about the term force here. So in our next class, we will start discussing about laws of motion. So in today's class, if you have any doubt, you can call on the same day of the video set. Thank you.